Next question I want you to do is long question 1. A business supplies the following figures about its activities. The forecast output is 20,000 units. Selling price per unit is €50. Fixed costs are 300 grand and variable costs per unit are €20. Illustrate by means of a break-even chart. So they want you to draw a break-even chart, and on it they want you to show where the break-even point is, where's the profit at the forecast output, and what's the margin of safety, or where is it? So not only do you have to show it on a break-even chart, you also have to calculate those 3 things as well, which is what we've been used to doing. That's going to get you 25 marks, your calculations and your graph. Part B then, we have an adjustment. So what I want you to do is pause the video, go and answer part A first, draw your graph, come back and check the video for the solution to make sure you've drawn graph A correctly and you've done your calculations correctly before you attempt to do part B. Okay, so we are calculating the break-even point. So it's fixed cost divided by contribution per unit. The contribution per unit is selling price take away your variable cost. So that was €50, take away €20, which gave me €30. That's your contribution per unit. So my break-even point works out to be 10,000 units, and then you can multiply that by the selling price to get it as a monetary value. So €500,000 is my break-even point. That is how much I would need to produce and sell just to cover my costs. The margin of safety is your forecast output, which is 20,000 units. Take away your break-even point that I just calculated. So my margin of safety is also 10,000 units. Turn that into a monetary value by multiplying it by €50, which was the selling price per unit, and that gives me 500 grand as well. My input-output table. I've only done 2 columns. You don't need to do a third, but you can if you want. If you did, I would have had 0 units, then I'd have 10,000 units, and then 20,000 units. So total revenue, if it's cost or selling at €50 a unit, 0 by €50 is 0. 20,000 units by €50 is €1,000,000. Fixed costs were 300 grand constant. Variable cost per unit was €20 a unit. If I produce nothing at €20, it's costing nothing. If I produce 20,000 units at €20 a unit, it's costing 400 grand. Fixed plus variable gives you your total costs. Okay, that means overall profit then, total revenue 1 million, take away your total costs at forecast output. So when I'm producing and selling 20,000 units, my profit will be 300 grand. Okay, now we're going off to plot our points and draw our break-even chart. Okay, quantity axis or total output axis. Because I had to go as far as 20,000 units, I've gone out in 5,000s. Okay, and it's consistent. So you could say like every 2 centimeters is 5,000 units. My revenue and costs in euros, okay, the y-axis, I've gone up in hundreds of thousands of euros. Gave the chart its name, break-even chart. Now, was there a name on the company for this? Let me just double check. No, there wasn't. If there was, I would put the name of the company on the break-even chart as well. Okay, fixed cost 300 grand. My total costs, the first coordinate was 0, 300, and the next coordinate was 20,000, 700,000. So plot them, connect to 2 points. Total revenue was 0, 0, and then 20,000, 1 million. Plot the point, connect the 2 points. Total revenue. Where total revenue is greater than your total cost, this little yellow highlighted region, that's your profit region. Where total revenue intersects total cost, that's your break-even point. And if I drop down a vertical line, it looks like it's hitting 10,000 units. That's what we had said our break-even point was. So it's looking accurate. The margin of safety then is the difference between your forecast output, 20,000 units, and your break-even point, 10,000 units. There's your safety net. And that's all we were asked to illustrate on the graph. Okay, we are now going to use the exact same graph and we're going to do part B on top of it. So part B said, outline the effect on the break-even point if variable costs increased to €25 per unit. So they didn't increase by, they increased to. They were €20 a unit. They are now gone up to €25 per unit. So I have to outline what effect it will have on the break-even point, okay? Then I also have to illustrate that effect on the break-even chart. So this is for 10 marks. So I'm going to recalculate my break-even point because obviously if my variable costs are changing, my break-even point is going to change. Right, so this is my new break-even point. It's fixed costs divided by your contribution per unit. Again, how did I get the contribution per unit? It's selling price, take away your variable cost per unit. Selling price was €50. Take away the new variable cost per unit, which is €25. 50, take 25, leaves you with 25. So now my new break-even point is 12,000 units. That's an increase of 2,000 units from part A of the question. So if I go back to part A, okay, it was 10,000 units was my break-even point. So now it's gone up to 12,000. So it's gone up by 2,000 units. So it's also going to have an effect on my margin of safety. The old margin of safety was 10,000 units. So I could have afforded to lose sales of 10,000 units and I would have still broken even. But now that my variable costs have gone up, my margin of safety goes down. So the new margin of safety is your forecast output of 20,000 units. Take away your new take away your new break-even point, 12,000 units, and that leaves me with 8,000 units of a margin of safety. That's a reduction of 2,000 units from what the original margin of safety was. So now I have less of a safety net, okay, as a result of my variable costs going up. So the question said, outline the effect it's going to have on your break-even point. Well, it's a one sentence really. My break-even point is going to go from 10,000 units up to 12,000 units. So it has increased by 2,000 units. And obviously that has a knock-on effect onto my margin of safety. My margin of safety is going to go down by 2,000 units. So it's gone down to 8,000 units. Right, I'm going to show now my new total costs will change. Total revenue does not change from what I had already calculated it. Fixed costs don't change. Variable costs changed to €25 per unit. So 0 multiplied by €25 is 0. 20,000 units multiplied by €25 is now €500,000. My total cost is fixed plus variable together. That's 300 and this is going to go up to 800. So obviously now my total costs have increased. So my new profit is going to change as well. Total revenue, 1 million, take away total costs of 800, now leaves me with a profit of €200,000. So it has reduced my profits. Okay, so my new profit figure is 200 grand. That is a reduction of 100 grand from what they were originally. So in part A of the question, my profit was 300 grand. So I have three things to speak about now when I'm talking about the effect on the break-even point. It has more of an effect than just adjusting the break-even point. It affects the margin of safety and it affects the profit. And then I'm going to illustrate it on top of the old graph. All right, so there's my explanation. So I'll let you read that. Okay, so I've commented on those three aspects and now I'm going to plot my new total cost line. Okay, so that's the only thing that's going to be changed on the graph is the total cost line. So I'll plot my 2 points, 0, 300 and then 20,000, 800. And it's directly on top of the old graph that you had done. So this new little blue line, okay, so total cost new, whereas this was the original one. This is the new one that I'm plotting. So you can see it's above the old one because it's higher up, it's more costs. It's eating into the old profit, which was from here to here. This is now the new profit region. Okay, we now also have a new break-even point where your total revenue line intersects with your new total cost line, which is that point there. That's your new break-even point, whereas that one was the original break-even point. Or you can call it break-even point 1, break-even point 2 if you want. We also have a new margin of safety. Okay, the old margin of safety went from 10,000 units up to 20,000, but my new margin of safety is going from my new break-even point, 12,000, to my fixed output there of 20,000 units. Okay, and that's all you need to illustrate on your original graph. Show the new total cost line, show the new profit, show the new break-even point, and show the new margin of safety. And that is now illustrating the effect that a small change in the variable cost had on those three aspects. Okay, question 2. You can pause the video and go and do this question 2 next. Then come back and look at the solution and correct it. Okay, so Csoft Limited manufactures office chairs. To survive, it must cover its costs. Using the information below, illustrate by means of a break-even chart. So we have to draw a break-even chart. Illustrate the break-even point, the profit at full capacity, and the margin of safety. So we need to calculate those three things as well as illustrating them on the break-even chart. And there's the information they've given me. So I plan on producing and selling 70,000 units. The selling price is €40 per unit. Fixed costs are €1 million. Variable costs per unit are €20 a unit. Okay, I'll come back and I'll do part 2 then in a second. Okay, there is your break-even point. There's your margin of safety. How I got the monetary values. I multiplied 50,000 units by the selling price, which was €40 per unit. Okay, so I have the input-output table just slotted in there as well if you want to double check. And if you have any inconsistencies in your graph, if it's not looking like mine, now you could have a smaller condensed version. It's based on what way you went up on the y-axis or what way you went out on the x-axis. Like maybe you didn't go out in 10s, you might have gone out in 20s or 5s. So that'll be the difference. But just as long as you're consistent, so like every 2 centimeters, I said that was equivalent to 10,000 units. So the next 2 centimeters is another 10,000 units. Be consistent or it will not be accurately drawn. Okay, I'll go back then to part B. It says if variable cost per unit decreased by €5. It didn't say it decreased to €5, it decreased by. So what was it originally? It was €20 a unit. Well, if it's now being decreased by €5, that means the new variable cost per unit is €15. What effect would this have on a new break-even point, margin of safety, and profit? So it's going to affect those three things. Well, if your variable costs are going down, you're going to have to assume your profit goes up automatically. It should do if nothing else is changing. Okay. Then break-even point should drop. Margin of safety should widen as well as a result. So I'm going to have to do those new calculations, but also then I have to illustrate the effect on top of the break-even chart that I just drew. Okay, so you can now pause the video, go and do part B or part 2, and then come back and correct it. Okay, so these were the figures that were given earlier on. I've already adjusted the variable cost. Okay, it was €20 per unit, but now they're telling me that it has decreased by €5. So it's now going to be €15 per unit. Okay, so I'm going to go and calculate the new break-even point. Okay, fixed costs all over contribution per unit. How did I get contribution per unit? It's selling price per unit, which is 40. Take away your variable cost per unit, which is 15, and that'll give you 25. So my new break-even point is 40,000 units, or 1,600,000. And again, how did I get that? I just multiplied my 40,000 units by the selling price per unit, which was €40. And that gave me €1.6 million. Okay, my margin of safety. So it's the forecast output, take away the break-even point. So I plan on producing 70,000 units, take away the break-even point. So 30,000 units would be my safety net. Again, multiply that figure by €40, which is the selling price, and that will give you your 1.2 million there. Okay. Now, my input-output table. Revenue isn't changing. It's staying as what it was originally. Fixed costs are not changing, but variable costs changed to €15 a unit. So 0 units by 15 is 0. 70,000 units by 15 is €1,050,000. If you add fixed and variable together, you get your overall total costs. So 1 million when we produce 0 units, and then €2,050,000 when we produce 70,000 units. So you can see your total costs now have adjusted. Okay, they are less than what they were originally. So what would my profit now be? Total revenue at forecast output was 2.8 million. Take away your total costs, which was 2.05 million. So that's going to leave you with a profit now of €750,000. So my profits have increased, which is what you would expect. If your costs go down and nothing else changes, you would expect your profits then to go up. Okay, so my new profit, €750,000. So that's the first thing, okay? It said outline the effect. So I've calculated the effects. I now need to just briefly outline, okay, with your couple of sentences, and then show it on the break-even chart. So I'm going to be graphing a brand new total cost line. That will be the only thing new onto the graph. So a brand new total cost line. We'll have a brand new break-even point at 40,000 units. We'll have a brand new safety net, margin of safety of 30,000 units. And our profit section is going to increase. It's going to widen the profit region to 750 grand. Okay, so I'm doing this on top of my old graph, the original one I just drew. So these were all the original figures. Okay, that was the original profit region. That was your total cost line, the original one. That was your original break-even point. That was your original margin of safety. So now, based on my new total cost line here, okay, my figures, I'm going to plot those 2 points. So 1 million is my starting point, and then 70,000 units and 2.05 million. So 70,000 units up to 2.05 million, which will be roughly around there. Plot the points and connect them. Label it. That's my new total cost line. Where my new total costs intersects with my total revenue, which is at that point right there, that's my new break-even point. And if I drop down a vertical line, it looks like it's 40,000 units, and that's what we had said the calculation was. So that corresponds to my calculation. That was the old margin of safety, but my new margin of safety is now going to be between my new break-even point and my forecast output. Last thing I need to show is where's my new profit region. Total revenue, take away the new total cost line. So all of this region in here is going to be my new total profit, which was €750,000. You could also mark that in just underneath it, 750,000. Okay, and that is now the effect on my break-even chart. And I have the outline down below. So when variable costs decreased by €5, they went down to €15. My total costs were reduced by 350 grand, down to 2,050,000. So you're comparing it what they originally were to what they are now. This meant profits increased by €350,000 up to €750,000. The margin of safety widened by 10,000 units out to 30,000 because it was 20,000 units. The company is in a much better financial position now as a result. Okay, so that's 2 more long questions, and that's how they come up in the exam papers.